hear the word all the time. What is a abelian, non-abelian?
The historical answer is there was a Norwegian professor called Abel who died young from tuberculosis, I think, who was very instrumental in creating a modern theory of groups in 19th century. It turns out they're very easy groups to work with, and you know that already. If you have number of matrices and they all commute among themselves, then you can use one of them to produce natural coordinates for all of them. And we use that all the time. We use the shift matrix to produce natural coordinate for all translational invariant operators. And that's why we can write them all in terms of Fourier components. So whenever you have a set of elements for which the order doesn't matter, that's called abelian group. And it's the simplest possible group to work with. Non-abelian is every other group, and almost any interesting group is non-abelian. For example, rotations on a sphere, the order in which you rotate things along meridians and parallels matters. They're not commuting. That's example of non-abelian. So that's, abelian always means you can do operations in any order you wish. Non-abelian means you have to keep a track, and the way you keep the track is you compare the two orders and subtract them. That's called a commutator. And then you study algebra of these commutators, what happens when you have to do it a few times. And that's the basis of all non-abelian groups, basically of all groups that we care about, like, rotations in 3 dimensions, or in particle physics, special unitary rotation of functions with 3 components, like 3 quarks or like 3 colors of a quark, etc.